Hello and welcome to this video where I will address the issue of the zero error of a Vernier calipers. One of the features that a measured physical quantity must have is accuracy. A measured value is said to be accurate if it is closer to the actual value. One of the main aims of taking measurements is to ensure that such measurements are as accurate as possible. There are several factors which affect the accuracy of a measurement. Some errors are due to the experimenter, while some are due to the instrument which is being used. One of the most common errors which is due to the instrument is the zero error. This error mostly affects instruments which have a scale on them. A zero error on an instrument makes the measured value to be either greater or smaller than the actual magnitude. Now let's have a look at the Vernier scale. Now, I have already dealt with the least count of the Vernier calipers. I want to look at the zero error which is associated with the Vernier calipers. But before I do that, I want us to look at the scale of a Vernier calipers which does not have a zero error. Now, for you to test whether a Vernier calipers has a zero error or not, you need to close the jaws. So make sure the jaws are closed with no object in between. Then look at the 0 mark on the Vernier scale and the 10th mark on the same Vernier scale. The 0 mark on the Vernier scale must coincide with the 0 mark on the main scale, while the 10th mark on the Vernier scale coincides with the 0.9 centimeter mark on the main scale. When this is the case, then this Vernier calipers does not have a zero error. Now over here, I have enlarged that diagram so that when it comes to studying the zero error, you will be able to understand what it means. So this scale over here is the same one over here, only that I've made it a little bit larger, and I have included a division on the left-hand side equal in length to 0.1 centimeters. This one here, because sometimes this one will be found to the left hand side and sometimes to the right hand side. I want us to start with the positive zero error. So this is the scale if the Vernier calipers does not have any error. Like you can see, this 0 coincides with this one and the 10th mark coincides with this mark here. So this scale, there is no zero error. But if you close the jaws and you find that the 0 mark on the Vernier calipers does not coincide with the 0 mark on the main scale as shown, and that the 0 mark on the Vernier is ahead of the 0 mark on the main scale, that is a positive error. And the positive error will be the reading on the Vernier scale. For example, you can just see, let's compare this diagram and this diagram. You can see that the least count, this division and this division, they are separated by one least count. This one and this one, they are separated by two least counts. And this and this, they're separated by three least counts. They increase like that. So if this Vernier scale were to move ahead just slightly, the next division which is likely to coincide with a division on the main scale is this one. And that is what has happened. It has moved through a distance equal to one least count. So the zero error here is positive 0.01 centimeters. If we repeat that with a different Vernier calipers, and this is what we see, we now see that it is the second division which coincides with the mark on the main scale. It means that this is the zero error and it is two least counts. And you can see it is the second division on the Vernier scale which coincides with the division on the main scale. So the zero error here is positive 0.02 centimeters. and so forth. If it is a third division which coincides, then the zero error is positive 0.03. Now let's have a look at the negative zero error. For the negative zero error, the zero mark on the vernier calipers must be to the left hand side of the zero mark on the main scale, like this. Again, I have retained these just to show you how the scale looks like when the vernier calipers has no zero error. So this one has got a negative zero error. Determination of the negative zero error gives many people a lot of challenges, but this need not be the case. Let's start from this diagram here. When you look at this diagram, you can see that this first division on the main scale and the first division on the vernier scale, they are separated by a distance equal to 1 least count. Now let's look at the 8th division on the main scale and the 9th division on the vernier scale. They are also separated by a distance equal to 1 least count. So if the vernier scale were to move to the left just through a short distance, the most likely division to coincide with a division on the main scale is the 9th division. And that is what has happened here. It has moved to the left through a distance equal to 1 least count. So you'll find that it is the 9th division on the vernier scale which coincides with a division on the main scale. So if we name these divisions like 1, 2, 3, 4, 5, 6, 7, 8, 9, then you find that it is the 9th division which coincides. If you are to determine the negative error, and this is where most people make a mistake, they just take this 9 and multiply it by the value of the least count. That is not true. What I would recommend is this. Reverse the naming of these numbers in such a way that now you have 0 here and you have 10 here, so that this one becomes 1. And indeed, you can just say that the negative error is, or the zero error is negative 0.01. And indeed, you can see, even by looking at this, you can see this is 1 least count, but to the left. So it is a negative 0.01. If you were to move further on to the left, through 2 least counts, you'll find that it is the 8th division or the 2nd division if you are naming them from the left, 0, 1, 2. So the error is negative 0.02. And so forth. This error here will be negative 0.03. And that is how you determine the zero error of a vernier calipers, whether it is positive or negative. I hope this lecture has been useful to you. In the next lecture, I'm going to look at the micrometer screw gauge.